Okay, so we have to find V1. Okay, so pretty much we have to find like pretty much all of this that's given here. And we have to find the power that's been dissipated in a 12 ohm and 40 ohm resistor. So let's start with doing a mesh analysis. Let's call this IA. Let's call this IB. Let's call this IC. Okay, let's start writing the equations. So let's start with the equation for IA. So it'll be minus 15 volts plus 6 IA minus IB plus 10 IA minus IC. Okay, then let's simplify this. We have two like terms, so it'll be 16 IA minus 6 IB minus 10 IC. Okay, now let's do IB. IB will be 12 IB plus 6 IB minus IA. Simplifying it, we have 12 IB plus 6 IB minus 6 IA. Okay, so now we have two like terms here. So 12 plus 6, that's just 18. That'll be 18 IB minus 6 IA. Now let's do IC. So IC, it'll be 10 IC minus IA plus 40 IC. Okay, simplifying it, we have 10 IC minus 10 IA plus 40 IC. So we have two like terms here, so it'll be 50 IC minus, oh shoot, I forgot, it's minus 10 IA here. Okay, so continue as normal, minus 10 IA. Okay, so now we have three equations and three unknowns. Okay, so we see we can substitute IA for a lot of these. So for example, let's work with this one. We have 18 IB minus 6 IA. If we bring one of these to the other side, we'll have 18 IB equals 6 IA. Let's divide both sides by 18. So this will be 6 over 18, and that's just 1 over 3. Okay, now for the second one, we have 50 IC minus 10 IA. Bring one of these to the other side, it'll be 50 IC equals 10 IA. Divide both sides by 50. This cancels out, so we have IC equals 10 over 50, which is just 1 over 5. Okay, now going back to our original equation, we can start plugging these in. So we have minus 15 plus 16 IA minus 6. Recall IB is IA over 3 minus 10. IC is IA over 5. So it'll be minus 15 plus 16 IA minus 2 IA minus 2 IA. So it'll be minus 15 plus 16 IA minus 2 IA minus 2 IA, which is just 12 IA. Let's bring the 15 to the other side. So it'll be 12 IA equals 15. 15 over 12, that's just 1.25. And yep, okay. So that's what IA is. So let me erase all of this. So IA is 1.25. IB will be IA over 3, so it'll be 1.25 over 3, which is 0.4167. And IC, that'll be IA over 5. It'll be 1.25 over 5, which is 0.25. Okay? And now we can find I1 and I2. I1 is moving in IB's direction, so this is what I1 will be equal to. And I2 is moving in IC's direction, so this is what I2 will be equal to. Okay? Now we can find V1 and V2. So V1 will be equal to I1 times 12. So I1 is 0.4167 times 12. And that will be equal to 0.4167 times 12. That will be equal to 5 volts. Okay? And then V2, that will be equal to I2, which is 0.25 times 40. And that will be equal to 10 volts. Okay? Now we have to find the power that's been depreciated in those resistors. So the formula for power, hold on, let me erase all of this. Okay, the formula for power is power equals the voltage times the current. Okay, so for the power in this one, let's call it P1. P1 will be equal to V1 times I1. So V1 is 5, and I1, that is equal to 0.4167. So P1 will be equal to 2.083 watts. And then P2, which will be this one, P2 will be equal to V2 times I2. So V2 was 10, I2 is 0.25, so it'll be 10 times 0.25, which is 2.5 watts. Okay, and there's all your answers, and you could see it matches up with everything we have up here.